green, and blue. Using this notation, the color 238963 will be coded as EE093F. And the question asks, which of the following hex codes represent the color 14, 20, 255? Let me just plug my laptop in. So for number 18, we have 14, 20, and 255. So the 14 is equal to 0 times 16 to the first power plus 14 times 16 to the 0 power, which is equal to 0 E. And the next number we have is 20, which is equal to 1 times 16 to the first power plus 4 times 16 to the 0 power. Which is equal to 14. And 255 is equal to 15 times 16 to the first power plus 15 times 16 to the 0 power, which will equal F. So from here we can write this as OE 14FF, which tells us that the answer to number 18 is C. Number 19. In Java, a variable of type int is represented internally as a 32-bit signed integer. Suppose that one bit stores the sign and the other 31 bits store the magnitude of the number in base 2. In this scheme, what is the largest value that can be stored as type int? So for number 19, we know that we have 31 slots for storage because one of the slots is taken up to store the sign. And so if we only had one slot, the maximum binary number that we could store in that slot is 2 to the first power minus 1 because it's stored in base 2 and one of the slots is taken. And if we had 2 slots, then the maximum binary number would be 2 squared minus 1, and that would equal 3. And for example, if there were 8 slots, then the maximum binary number that we could store would be 2 to the 8th minus 1, which equals 30. Equals 31 slots. Number 20. Consider this code segment. What will be output after execution of this code segment? So at the beginning, int x equals 10 and y equals 0. So we have that noted here. And it goes through this while loop. So if 10 is greater than 5, it enters the while loop, which it is. And y then equals 3. So after y equals 3, there's another while loop, and it activates if y is less than x. And since 3 is less than 10, it goes into the second while loop as well, and you get y times equals 2. So y then becomes 3 times 2, which is 6. And then we have an if statement that asks if y mod x is equal to 1, which it isn't because 10 mod 6 does not equal 1. And then this inside while loop repeats because y equals 6 and 6 is less than 10. So y then equals 6 times 2, which is 12. After that, it skips the if statement again and goes to this x minus equals 3, and x then becomes 10 minus 3, which is 7. And the first while loop restarts, and since 7 is greater than 5, it enters the while loop, y equals 3 again, and the entire process that we had before is repeated. So after it changes the value of y 3 times, it goes back to x minus equals 3, and we get x equals 7 minus 3, which is 4. And since 4 is not greater than 5, it does not enter the while loop for a third time. So our final values at the end of this code segment are 4 for x and 12 for y. So the answer to this question will be D. Number 21. So for this question, they give us a code segment here, and it asks, which of the following values of num will result in valid having a value of true? So valid is equal to check number of num, so basically whatever this code returns. And so let's see what this code does. You have 6 integer values here, and so the first thing it does is it does n mod 10. So it takes the first digit of any of the numbers, so for example, if we had 6, 1, 4, 3, check digit mods this by 10, and it equals 3. So check digit is equal to the first number of any of the choices, and n remaining is then equal to the number that we have, which is 6143 divided by 10, which gives you 614. And it then takes that value and stores it in n remaining, and d3 is then equal to n remaining, so 614 mod 10. So d3 becomes the value 4. And then after that, n remaining becomes n remaining divided by 10. So since n remaining was equal to 614, it then becomes 61, and d2 becomes n remaining mod 10. So d2 is just equal to 1. And from there, n remaining is divided by 10 again, so it's just 6. And then d2 becomes 6 mod 10, which is 6. I mean, d1 becomes 6 mod 10, which is 6. And then at the end, the variable rem equals d1 plus d2 plus d3 mod 7. And then it checks if rem is equal to check digit. So what this program basically does is it finds the remainder when the sum of the first 3 digits is divided by 7, because d3, d2, and d1 are just these 3 digits of your number, and it mods that by 7, finds the remainder, and it checks if the remainder is equal to the 4th digit, because check digit is this digit over here. So, and if it's equal, it returns true. If it's not equal, it returns false. So basically we have to find which value here, which of the values here have numbers where the first 3 digits, mod 7, will equal the last digit. So the answer choice that works for is answer choice B, because 6 plus 1 plus 4 mod 7 is equal to 4. Because we have 6 plus 1, which is 7, plus 4 is 11, and 11 mod 7 is equal to 4. So the answer to number 21 is B. Number 22. What is the purpose of the local variable n remaining? So choice A says, it is not possible to separate n into digits without the help of a temporary variable. And this is incorrect, because instead of using a temporary variable, we could have just taken these sequences that we stored as variables and set the other variables equal to those sequences, rather than such as, instead of n remaining, we could have just put n divided by 10. So we didn't need a local variable in order to do that. And choice B says n remaining prevents the parameter num from being altered. And this is false, because num is passed by value and therefore won't be altered when the method is exited. So this is false. Choice C says n remaining enhances the readability of the algorithm. And this is true, because instead of a bunch of sequences of divisions and mods, you have variables. So this looks like it will be the correct answer. Choice D says, on exiting the method, the value of n remaining may be reused. And all local variables are destroyed when a method is exited, so this is incorrect. And E just doesn't make sense, because there aren't any sides to the division. So the answer to 22 is C. Number 23. What output will be produced by this code segment? So we have a for loop and then another for loop inside of it. And so the first for loop starts at I equals 5, and the inside for loop starts at the initial value of I, and it goes all the way down to 1. And so when I equals 5, we're going to print 2 times 5 minus 1. So the first number that we print here is 9. So we can automatically eliminate D and E. And after that, it prints, and then J decreases by 1, it becomes 4. So it then prints 2 times 4 minus 1, which is 7. And then it prints 5, 3, and the last number that it goes to is 1, and 2 times 1 minus 1 is 1. So, and in the next row, I equals 4, and int j equals 4. So it prints 2 times 4, which is 8, minus 1 is 7. So we can eliminate this because it starts at 7. And the loop will stop after it reaches j equals 1. So the last number it prints in a row is always going to be 1. So the answer to this one is B. Number 24. Which of the following program fragments will produce this output? So the first program has a for loop, which prints 6 different things. So the inside for loop starts at k equals 1, and it prints 2 times k if k equals I. So for example, since I equals 1 the first time and k equals 1, it'll print 2 times 1, which is what we have here. And so every time I increases, it prints 2 times that number in the correct place. So it gets the sequence